I'm going to talk about the vocabulary that goes along with section 5.8 for scatter plots and trend lines. You'll find the directions for the graphing calculator and how to graph lines on my website, but this is just going to get into some of the vocab that you're going to be responsible for and to help clear up any questions you have recording in regards to words that they may present to you. All right, so basically I have 3 scatter plots on this screen here. And with each of these, you're going to notice that there's a pattern. And right here, if I were to draw a line of regression, it kind of best represents this line. You're going to see that the graph goes from the lower left to the upper right. So that's considered to be a positive correlation. Okay? If it goes from here and it goes from the upper left kind of going down to the right, we're going to say that that's a negative correlation. And over here we can see how the graph is all scattered. We can say that's a 0 correlation, or we can say that there is no correlation between the graphs. There's no relationship. Okay, so you're going to be looking at some graphs in your homework and different projects where you're going to be looking at it and saying, okay, what type of a relationship do these have? Is it a positive, negative, or none? Okay. And you're also going to be asked when you get a scatter plot to make predictions. Okay, and there's 2 cases of predictions that you can look for. So let's say you have your set of data and it all falls in here, and you get your line of regression that goes through right here. Okay, and you basically had data at A and B. If you are asked to find a data point somewhere in between A and B, that's called an interpolation. Okay, you're trying to estimate a value between the 2 known values. Okay, and then if in another case, if you are looking for, here's your A to B, and then you're given a data point, way into the future. So this could be population. This is time, and you could say, in 2040, what is the prediction for the population? That could be the type question. And this data point is outside of your data set. That's called an extrapolation. Okay. And the next terminology that we're going to look at, a term called the correlation coefficient. Okay, so this is really important because you could have somebody making a prediction and using data like this back here that has no correlation. So we need to know how close the data is and whether it's a strong correlation or a weak correlation. Okay, so basically we have this understanding. On your graphing calculator, you're going to get values for R. So basically the correlation coefficient is an R value. When you take a statistics class, you'd learn how to calculate the R, but at this point, if we have an R value of equal to 0, that means that there is basically no correlation. It's very, very weak. The data will look like it will look very scattered. So a weak correlation would look like very scattered, no correlation. Now, the stronger you get to a positive one, the stronger of a positive correlation it is. If it's a perfect one, then all the data is perfectly on a line. So let me just give you an example of each of these. Okay, so if you were to have a positive correlation of 1, you'd have a set of data points, and all of those data points are exactly on the line. Okay, as soon as you get further away from a positive one and you end up over here, you're getting some data points that might be a little bit off. Okay, and then when you get close to 0, the data points are all just scattered and there is no correlation. Okay, so then if we're looking for a negative correlation, I'm going to be doing something like the data points. This would be a -1 here. All those data points are exactly on that line right here. Okay, and then as we get closer to 0, we might get some data points that are further off, but there's still a negative correlation. And then basically when we get to 0, again, it's all just scattered. Okay, and lastly, these are just some examples of some R values. So this has a perfect R value of -1. This has an R value of -0.94, very close to a -1, but they're not all on a line. Okay, and you'll see this is pretty close to 0. It has an R value of 0.08, not much of a relationship. This has an R value of 0. Okay, this has a positive correlation. They're not all on one line here. And this one has an R value perfectly because all the data points are on 1.